Hello.
Hey, good evening. All right, so I think we could get started. Yeah, BlueJeans is not letting me paste in the chat, so I can't link to the uh, YouTube ads, but there's three Rados topics today, basically. The first one is about config profiles. So the idea here is that um, folks deploy stuff in many different kinds of use cases and different kinds of environments, and um, one of the our existing kind of defaults are pretty well tuned for high performance servers. But many folks are starting to deploy stuff in more constrained environments, whether it's for use as a home hobby cluster or an enterprise kind of edge deployment, where it might only be a single node or a small number of nodes with little memory and CPU available. So the idea is that we could have kind of performance profiles for applied to the cluster that would affect the defaults for a bunch of these kinds of tunables that control how much CPU memory we consume. Those kind of some obvious ones, like the daemons that have OSD memory targets, like the OSD, the MDS. There are less obvious ones for like CPU that might be more related to number of threads, especially for things like RGW, MDS, that are more about passing data through themselves rather than storing it directly. I think there's also a lot of investigation that we could do to figure out exactly which things we could tune more to kind of get the lowest possible resource usage in scenarios that demand that. Like talking to Mark Nelson earlier, I think he was thinking that the major contributing factor there is the OSD caches, especially for BlueStore. So reducing the size of the Roxby cache and BlueStore's cache itself would be the main memory piece there, most likely. But I think it's been some time since we tested about that kind of scenario and really tried to tune it.
Would these all be like config options specifically? Would this like
Yeah, I'm kind of
adjust
thinking
the
this would be like
profile?
like similar to how we have like what we did with like quality of service profiles for Pacific, where we have like an option called like QS profile that
Okay.
controls a bunch of other options. It would act similarly. So you set like performance profile, um, the like default or to limited, or I'm not sure what a good name is for like the resource constrained environment is. Um, and it would change a bunch of these config parameters for you.
So if you enable a profile, then it forces a value for a bunch of config options,
Right.
basically, and you can't override it unless you disable the file.
Well, I guess there's a few ways to go there in terms of overriding. What we did with the quality of service profiles was that we had a third profile called custom that lets you do whatever you want with any of the settings.
I see.
But if
Okay.
you're not using the custom profile, then there's a few that you can't change.
Right.
I think there's some valid discussion to be had about what that UI should look like, but
Mhm.
Yeah.
like it seems like it should be straightforward to overwrite a single config on a profile, and it should be the case that if you keep that is if you like do that override and then the config changes in a subsequent version of Ceph, all the ones you didn't override should change, but not the one you overrode. Some
Yeah.
behavior like that, but
Yeah.
I don't think any of that's as important as the general existence of the profiles.
Yeah.
Yeah, I think that makes
I was just
sense. And that kind of just describes like the profiles changing the default values instead of setting
yeah.
the values directly,
Right.
right?
I think that's the right
Right.
intuition, yeah.
Yeah, I guess I was imagining whether this was something that was part of the config subsystem, where you set a profile and it sort of like adjusts all the default values. So you could still do a config get, for example, and you'd get the adjusted default that's set consequent to profile. Because if you built that sort of something like that into the config system, then you could imagine profiles for all kinds of different config options, not just in this like specific case.
Yeah, and I think you're right. I think config get should always return the actual in-use value that
exactly,
the daemon itself is going to see. There should be no confusion on that point.
Yeah.
I guess the other question that I'm thinking is what profiles should we have? How many of these profiles, or what classification should we make?
Yeah, so I guess that. I mean, go ahead, Tim.
I was going to say there seem to be good arguments for both this edge or whatever constrained resource. May as well just call it edge resource one and high performance. Those seem like two regions of the design space that are distinct and both directly useful.
Yeah.
So at least two.
Yep, those clearly have use cases at the moment as well.
The other thing that comes to mind is we have a bunch of existing options for differentiating between different types of hardware, SSD and HDD. Those could be kind of subsumed into a profile.
Model, yeah, a profile model, right?
Yeah.
One could just set like a, yeah.
Like it could be like a disk profile or something that tunes all those current parameters based on your disk type. Yeah, are there other sorts of environments that anyone's thought of that might be useful to have a profile for? Well, it seems reasonable to start with two, and if we need more, we can always add them. But
yeah, one thing I was thinking is it's more for the testing part of it. We could create artificial profiles that we want to test with. They may not necessarily be what users run with, but they could be like extreme, just to make sure things still work.
Sure.
That raises another question. So, I mean, I kind of hate to over-design this part, but it may be worth considering whether we want to also make it so that large deployment users can create their own custom profile that encodes what they think the default should be for their cluster. It might be a good way to tie those UI elements together. Something like it lives in the monitor, you set this JSON file that encodes the defaults that should exist cluster-wide, and it behaves kind of the same way as what we're describing. Any further config values you set on an OSD basis, override that, but only for that OSD. I don't know that it's worth attacking at the same time, but it's probably worth briefly considering. That would also address the testing use case, because Duthology could just make one of these. We wouldn't need to encode it into the base.
Yeah.
Yeah, it sounds like a nice simplification to be able to import and export. It's essentially like importing and exporting a Ceph.conf file, isn't it? But encoding those as defaults instead.
It's more, so once you think of it that way, I think that's right. The config change would be essentially permitting layered configs.
Yes.
Like from an implementation standpoint, it probably looks something like the config now has some kind of a baseline config that lives above the most basic defaults, but below the specifically set ones.
Mm-hmm.
Something like that. You'd need a way to dump all this stuff, so there'd need to be UI elements for exposing that.
Mm-hmm.
But after that, yes, I think you're right. It's a matter of setting a set of layered Ceph.confs.
Yeah, you need to define an order that the layers are applied, basically.
And we can be opinionated about that. We can say there are only 3 layers. There's the baseline default that you don't have the ability to change. There's the specified profile, and then there's the immediate config settings.
Yeah, I mean, there's the config subsystem already has like I think like 5 different ordered things, sources of a
Yeah.
config value, and it tracks where they come from. And so you could just sort of insert profiles in there somewhere. But if you had multiple profiles that both touch the same value, you need to define which profile, what order the profiles apply in.
That may not be so bad. We could just like not allow that. There could be exactly
Or
one
just
profile.
have a well-defined order.
Or that.
They're probably not touching us enough. But, yeah. Yeah. It's just remembering the asoc command config diff on a running daemon will tell you, it'll show you the daemon, all the different values it has in the different layers, and which one is the actual one it's using, including the default, and then the one that came from the config, one command line, from the environment, from the monitor, and so on.
That's most of what we need then.
Yeah.
Yeah, it sounds like this would be a relatively small addition to that. Just in config.
Yeah, I think so,
hierarchy.
yeah. It just needs to be, I mean, it could even be implemented at the, well, maybe if we implement it, it could implement it entirely in the monitor, and then it would be, the monitor would feed it through to the daemon. And so as far as the daemon is concerned, the config options coming from the monitor. Or you could plumb it so that at the daemon level, you can actually see the source. That might actually, I don't know if that's more trouble than it's worth.
I guess you might have some complexity around those that aren't able to talk to the monitor for some reason, just like we do today with like
Yeah,
config options.
yeah. It's a pretty small, narrow set of options where that's possible, and I think this wouldn't be ones that we would care about touching with the like stuff related to bootstrapping.
Right.
And even then, it'd be like literally have a bootstrap step where we talk to the monitor to get the config, and then we like restart the whole process with that config. So yeah, it should be fine.
Yeah, it's not a new problem. Same thing with the existing settings.
What was the motivating driver? So it's like edge. So yeah, so like large scale options or
Like edge
edge low
deployment,
resource.
where you want to,
Yeah,
like that, where you want to kind of minimize the resource utilization,
yeah,
but still have all the functionality of a
yeah.
Ceph
I think that
cluster.
makes sense because you want to like do all these sort of in unison. Would there be would it make sense to have these like where you can apply profiles to a subset of the cluster, or would a profile be global?
I think that would be useful, but I think that's like a part 2.
Yeah.
Yeah, it feels like that might get pretty complex just managing the configuration of your cluster at that point.
Yeah.
It's worth thinking about what that would look like as the configs percolate through, just so we don't like make choices that make that annoying later. But I think it's useful even without that feature.
Well, if for any given profile you say that it's driven by a named config option, then you could set that config option. So like say the OSD scale or whatever OSD profile is has a set of key value pairs, and you have all the different like values for it. You could define what the config option is that sets the profile, and then you could set that using the normal like hierarchical whatever config thing that you
Yeah,
do.
you could say this
Set
rack
it for
takes
one
this
OSD or for
profile.
one rack or globally or whatever. Yeah, I think you could make it all fit together.
Yeah, it seems like a pretty natural way to do it, actually.
You could even make the profiles themselves be like a config value. It's like a JSON dictionary of like profile to a list of a dictionary of option names to values or something like that. It might look kind of gross inside a config option, but you could put it in config key or something.
Yeah, I mean, we were describing a pretty general structure, so it could be literally a general structure that people could set.
Yeah.
Yeah, that seems like it could be like a nice part 3 or something for like the custom profile idea. With some of the pre-existing ones already defined. in terms of the actual options that we need to set, I think we'll need to and determine a lot of those experimentally to see what really makes a difference. I think today, in the recent past, I think Mark has tested kind of like OSD scaling down memory to like 2 gigs or maybe 1.5 gigs, but there are probably some other things that we can do to make that minimum even lower. Okay, should we move on to the next topic? These stages still taking notes here, but we can start just describing the next one a little bit. So this is around how we could handle pools with no replication better, particularly how to deal with EAOs on the client side. Because if this kind of a pool is accessed by an RBD client, for example, it's got a file system running on top of its local lock device, and if a file system like ext4 or XFS starts getting IO errors because the disk backing in that pool died, it's not going to behave well. It's going to essentially corrupt its local file system if it gets some EAOs and some successful writes. So the idea is to prevent the client from getting any successful writes or reads as soon as it starts to fail. So basically, as the first EIO it gets, it just continuously returns EIO for that device until it's unmapped. And there's a couple ways that we thought of implementing this. One is based in the OSD map. So you could add a pool flag that indicates this pool is entered an error state. That way the OSD would also be able to return the EIO directly to the client in case the client didn't support this yet. And it would work well with clients mounting from multiple places like Ceph. Another way to handle it would be purely client-side, so that like the RBD library LibRBD user space or the kernel client would detect an EIO and just the first time it has to respond that to the client to the upper layer, it just continues to do that, keeping track of that in its own memory.
What happens if we just delete the pool?
Are we sure we never return EIO immediately? Or sorry, are we sure we never return EIO already?
I mean, the current Rados behavior is just to hang, right? If the OSD is down or the cluster is unavailable or whatever, it hangs indefinitely.
There's some kind of
thought there
error.
was some weird.
There's some kind of timeout somewhere in RBD, but you have to turn it on.
Yeah, and it doesn't work well.
Yeah, the client-side timeouts are there just for like, they were designed only for like applications that could handle those errors, basically. So like a liberator or like the CLI or something that's expecting to be able to be interactive and responsive and doesn't mind if some requests that's sent out fail. But a file system can't deal with that kind of like a local disk doesn't usually fail that way, where it tells you some errors back, but then completes a bunch of your other writes that are still being written out. So that's essentially why the local file systems get corrupted in that kind of situation.
I was asking about EIO because I thought there were some narrow cases where we could actually return them if we got it on a read from the primary. No. Oh, okay.
I mean, there might be a bug like that, but no, not on purpose.
Okay.
If Rados is damaged and you try to read a damaged object, you get an EIO, right? Cases.
You don't get it. You don't get it to the client though. You get it, and
Like it crashes the OSD or something.
Oh,
you
yeah.
get recovery triggered, or you crash the OSD and an
Yeah.
upstream
That's good.
disruption.
Okay.
All right. Well,
Anyway,
I mean, any solution like this is going to need to be both a client and a server thing, and it's probably going to be racy, which
disagree.
is why I was concerned about it the last time it came up. What do you mean,
Well,
Pat, Sam?
so
I
the
mean,
reason why I'm partial to the pool EIO flag is that it separates out the sort of the implementation mechanics of having a well-defined point in time after which you return IO and before which you don't, and having it that ordering, so that it behaves the way like maybe a disk, if you disconnect the cable or something, might behave.
well,
Um,
yeah, but that's
separates
already
that
not
part.
true. If we
It
have more than
separates that
one,
from the policy
I
of
mean,
when you
if
No,
order.
it
we
means
have more than one OSD participating in the pool, that's already not true, though.
no. It means that any read that couldn't complete successfully will hang, and it'll hang until
Right.
something notices and marks the pool EIO.
Right.
It's fine.
Right.
It
So
interacts
I mean,
correctly with the current OSD.
so the challenge is that we can like brainstorm like situations where we should return EIO or maybe we shouldn't. Like maybe if the OC is down and it's been marked out and a certain amount of time has elapsed, maybe that works for certain cases, or maybe it's something else, but we're not really sure. But that's like I feel like that is that sort of policy decision of when we want to return EIO is tricky. And I'm not sure that there's going to be one answer that's going to be right for everyone. And so the pool EIO flag, the point is that it separates that policy decision of when to return EIO from the mechanics of
And
saying, okay, set the flag in the OSD map, and now we return EIO for that pool. And we can make sure that the client implementation and the OSD are properly coded so that that behaves in a way that doesn't have weird ordering issues or ops that are resubmitted later or happen to be in flight. Like we can make sure those issues don't exist. And then separately,
well,
we can have
that's
something else that implements the policy to be whatever we want.
that's what I'm saying though, because an OSD map flag is not point in time, not really. Because
So
if
what
you
is
have a pool that's across multiple OSDs, then like one of the OSDs can have the OSD map that says EIO, and one of them might not, and
it's
so you
not
get a
that. The
random
But
selection.
you could always
correct.
have an epoch, right? Like you have
No,
a
hang
pool
hang on.
creation epoch, you could have a pool dead
Yeah.
epoch.
The OSDs don't return EIO. The client does. The
Well, it's
client
both,
sees the OSD
actually.
map.
It's both.
That's not. Yeah, we just said both.
It has to be both
Or someone
because
said that both.
if you say you have a hung OSD and you have a bunch of ops that are in flight and are hanging, and then you set the flag. So those ops that were already in flight, maybe the OSD actually isn't down and the op like made it to the OSD was processed, or maybe it didn't. And so I think the implementation that made sense to me at least was that for existing ops on the client side, we don't do anything. We wait for the OSD to respond. Except if they're down, then that
No,
actually doesn't make sense.
I think
no.
this is
Yeah,
a lot
you're right.
The
simpler.
client
Yeah.
needs
I
that.
think the pool.
And
I think there's a simple way to do this. The pool EIO flag is semantically equivalent to deleting the pool. The OSDs immediately start getting rid of their state. They drop any in-flight ops, period. The client eventually sees the flag, goes, oh, that's why I didn't get any responses, and starts returning
Yeah.
EIO.
Yeah.
That would work. That's exactly how we handle full states in the OSD too.
Yeah. So I think the only thing to keep in mind is that that means that there's a situation where the op might have actually happened, but the client gets an EIO, which
Yes,
I think
that's
actually is what happens with the real disk too, right? Like,
Sure.
Well, actually,
Sure.
this
It
op
is
didn't
quite right.
happen because setting this flag made the pool stop existing. I'm arguing
well,
that
it doesn't have to. So I was assuming that this could be you could remove this flag. Like if some time went by and you're like, oh, I didn't actually lose the data. I don't actually want to delete it. Because if you just wanted, we could just delete the pool and we could get what you're talking about, right? And we just fix the client so that if the pool doesn't exist, then you get an EIO instead of ent or something like that.
So for the single replica case, I actually think this kind of scratch pool concept is the first use case we should worry about. And in that case, we shouldn't be encouraging people to think in terms of recovering these things. Clients should be designed around the assumption that these pools can die.
And I think in general that is the case. But if, say you're running your application and you've got 3 replicas and one of them's down and you have some policy that says, oh, if it's discounted for this long, then like make it look like the disk died and you start returning IO. And then, 12 hours go by and the administrator realizes that their system's down because that happened to too many disks. And it turns out we didn't actually lose any data. They were just offline for a long time. And the policy that was triggering this didn't realize that it killed 2 volumes that would break the application. All the data is still there, and so you would clear that EIO flag, and all the data would come back. The way I think about it is that's like the logical equivalent of unplugging the disk, right?
Yeah.
Like you start getting IO, the data doesn't go away, but and you can plug it back in, but it's like it's that like lever that we can then implement some policy on top of, or have a human intervene if they need to.
I mean, if our only if our only promise under those conditions is that every IO that was in flight or returned DIO either completed or didn't complete, then there's nothing to worry about, right?
My concern is just that like the semantics on this are going to be weird and.
Yeah, but that's okay.
Yeah.
I'm saying.
I mean, yeah, as long as it is okay. But
I'm trying to express the semantics we would get, then we can talk about that. So I believe the semantics we get are that any in-flight IO, that therefore return DIO, right? And any of those IOs may have completed or not, in any order.
Yeah.
Subject to Rados ordering guarantees, I suppose. So pipeline dops on the same object. Yeah, we'll have some specific point.
But we don't want to promise that to them anyway.
I think we can make that promise safely, and I think that's the strongest promise.
Yeah.
I think it's free, and I think that's the best.
But I mean, like,
so
I just want to be clear that we are guaranteeing that if you run this on a multi-OSD pool, weird operation orders are going to happen.
They're not really that different from the weird operation orders you get with a regular disk if you yank the cable, which is, I think, what Sage is saying. I can't think of a way in which this is not possible with a regular disk.
It's just going to be a lot more, mostly.
I mean, whatever.
No, I mean, like, with a regular disk, you might see out-of-order
in general you will.
But this, you're going to.
I mean, I personally don't think that the semantic difference matters very much, because I don't think I think we will almost never use this feature on purpose on a replicated pool. I think 99.999% of the time, this will be used immediately before deleting a pool. And that's the use case we really care about. So I don't think we want to go out of our way to like make this harder just to make replication behave in a slightly less weird fashion.
Oh, no, I'm not saying that. I'm just...
Well, so I think if we can express what they actually are, that's good enough.
So, I mean, I guess the reason I'm arguing is that I'm not sure we even want to bother putting this in the OSD map. Because, like, for the use cases we have, the client is going to need to cooperate anyway. And so I'm not convinced we don't just want to have it be in the client.
Well, I think there are two things. First, I think I disagree with Sam that this is 99.9% when you're going to delete the data, because I think that actually probably, I mean, sometimes that's going to be true, but I think there are going to be lots of cases where the OSD is offline for some reason, and that's going to trigger all the policy that makes these disks appear to fail. But the OSD actually isn't like, it's not because the disk failed, but it's because like the daemon wouldn't start or it hit a crash or I don't know, like whatever, it was hitting out of memory or hitting some bug.
What do you think the repair is going to be from that Sage? Like the repair is going to be they're going to re-replicate it somewhere else.
You fixed whatever the issue was that was preventing the OSD from starting. Like maybe the host is down. Like that, right? Like literally the host is down.
Yeah.
Right? And so you're saying, oh, Mongo, the disk failed. You set this flag, so it goes and recovers and we recreate the volume somewhere else, or hopefully. But maybe 2 hosts are down and you do it to 2 disks and Mongo can't recover, and so Mongo is stuck. You turn the host back on, they come up. Like, I think this might actually need to be coupled with like the equivalent of there's some other annoying OSD flag that's like auto out, so that if it comes back up, it clears it automatically. Or maybe we implement whatever. That's a separate discussion. But like, we need to plugging the disk conceptually or logically or whatever, metaphorically plugging the disk back in, I think is like a really important part of this. And that's why I think it should be a flag, because it's global state that allows all clients, everybody in the system, to agree on what happened and what didn't happen. Whereas if it's client side only implementing some timeout, then like there are multiple clients, they might disagree, they might have different notions of when the timeout happened and when it didn't. And there's sort of an unclear record of like that the client viewed the disk as failed and like the application moved on. Like here there's a there's like a well-defined
Well,
record of
it
like
sounds
what
it sounds almost like
Well,
they get the same semantics or like essentially what we're trying to achieve. It sounds like Sage is being able to recover data after the application has moved on in case of a disaster. Is that correct?
Say it again.
It sounds like you're describing being able to recover data in a disaster when you thought you lost it, but you didn't. The application's moved on in some way, but you find you have this like extra copy lying around. That sounds very similar to the semantics of like a delayed delete.
No, I see where Sage is coming
Maybe
from.
because I think
I feel like these two, one is a superset of the other, or one is a subset of the other, right? If we implement both, let us say we don't delete the data, and we leave that decision to the user to like, okay, I don't care about this pool, now go delete the data. Versus like, okay, I still want to recover something, so I will say, okay, I will do this manual. Like, let us say there's a cascading failure, like what Sage was describing, that all the nodes for even though their replica one pools suddenly became unavailable. At that point, we want to still recover the data, but it was just one-off incident that happened, and we don't care about the data. That should be like a manual, a decision that should be left to the user, how they want to configure the system, or if they manually want to go and delete that pool and don't care about the data anymore.
So my argument essentially was that it's not so much that they should be the same operation, it's that defining semantics for the failure case is hard. But Sage has a good point. There are a lot of situations where you actually would want to be able to recover them. So I guess if the semantics really are identical to a disk pool, then as long as we return DIO when we forced whatever RBD on the other side to be unmapped and then remapped, and therefore the files to remount it and MongoDB goes through its recovery process or whatever, then we do get well-defined state on the client side, and that should suffice.
Yeah, the client-side semantics are I think are pretty clear. They're very similar to the existing OSD map full flag and how the client handles that. But instead of blocking those ops, we return EIO for them.
And the scenario I was imagining wasn't so much administrator. It was OCS observed that for whatever reason a pool marked scratch or something, replica 1 became unresponsive, and it automatically took its own steps to increase the replication factor on Mongo or whatever. And because this is a thing that has to happen automatically, freeing up the space also has to happen automatically. So I assumed that this would be human out of the loop.
I think the failure part of it is human out of the loop, and I think that's what worries me the most is that you could have a situation where you have Mongo has 3 replicas, and then host 1 goes down, the automatic stuff triggers and like creates a new pool or something, and then a second host fails, and that happens, and we're at OCS is going to have like no idea that Mongo wasn't able to recover in time, or it lost too many replicas or whatever, because it doesn't know all the higher level stuff up further up the stack. So it shouldn't ever like go so far as to like delete data. I feel like that's
so
like
with the EIO flag. Fair enough. With the EIO flag, are we saying that the client actually doesn't return EIO until it sees that flag?
Yeah.
Yes, that's correct.
Okay.
That is, until it sees that flag, it does the current Rados thing, which is it just waits and assumes that it'll be okay later.
Okay.
I think actually we probably need like a last EIO epic field also in the PG pool.
Yeah, if you want to be able to turn it off, it's exactly the same as the full flag. We need a first like a full epic when it got full and when it turned off.
Just like that same ordering thing. It's the same as it'll be the same semantics as like the full stuff. We already dealt with all these like cases.
Yeah, exactly. I think the major difference is that on the client side, we never want to recover. Like once we've got to send EIO, it sounds like we want to force the RBD device to be like fully remounted.
Yeah, that RBD device should never ever return success again. It should, or sorry, that mapping, I should say.
Yeah, mapping.
Yeah.
You should be forced to unmap it, remount the file system, and then restart the application.
I mean, I think librd might Yeah, it probably doesn't already do that. XFS, for example, will do that if it gets an EIO on any of its metadata structures. It goes into like this zombie state where you can maybe read stuff or whatever, but it won't write anything else. Whatever. LibRBD should do the same thing. Like once it sees an EIO,
Is go read only?
it goes read only. Yeah.
And that's the thing we could also just do. I'm just really uncomfortable making the semantic change. Well, no, I'm like, we could also just make the whole pool go read only once we return EIO. So you can do the data recovery case, but not write the things that have had indeterminate order of operations on them.
So instead of returning EIO for reads, you satisfy reads, but only do EIO for write.
Well, I mean, because we're talking about unsetting EIO, but I wonder if we maybe just want to make it a read-only pool once we've ever set the EIO flag.
I don't think so, because it's just like
it might come back.
Yeah, it might come back, right? You might have done this because the OSD was offline for too long and you hit some timeout and you're like, we're going to figure this failed. But then like it turns out that you need the data and you have the data, and metaphorically you want to plug the disk back in.
Also, the semantic danger.
I know. I get the metaphorically plugging the disk back in.
Yeah.
I'm just
also the danger you're outlining is with reads, not with writes.
That depends very much on the application.
No, I mean reads are sufficient to demonstrate all of the properties you've expressed worries about. Like reads will return inconsistently committed objects across the set of IOs that were outstanding. It will not necessarily reflect an ordering just because you didn't perform a write.
Oh yeah, I just mean because most applications have extra checks when they're doing rebuilds from something like that.
Right, which is the reason we would force the RBD mapping to be recreated and the file system to be remounted.
Yeah.
You'd be doing a recovery as though you did a power off.
And why having it be a pool flag, for example, ensures that this happens consistently, even if you have multiple PGs. So maybe some OSDs are still actually responding and some aren't. So this has like a pool, whatever, barrier. Point in time equivalent.
Well, I mean, I want to again be very clear, Safe. That's not point in time. Like we've done a whole thing about how pool flags are not
for a particular mapping. It actually is, because RBD basically never allows multiple mappings to the same device.
Yeah,
there are no use cases where that's common. You're right.
Yeah,
if there were multiple readers and writers to the same RBD device, then you could demonstrate.
Even with one writer, if you have multiple PGs and 16 outstanding IOs in flight, you can have the last 15 completed, not the first one, because
it's point in time in the sense that it's point in time in the sense that the set of non-deterministic IOs is determined by the point at which the pool flag is set. It will hit the client.
Because the epochs increase monotonically and they spread whatever. It's point in time is the wrong word, but it's an ordering. It's a well-defined ordering where ops either happen before it or after it, and they never reorder across that barrier. Maybe barrier, whatever.
Barriers, I think the right term. Yeah, that seems good.
Yeah.
From the client's point of view, when it gets that map, every IO that completed before that point really completed. Every IO that was in flight at that time is not deterministic and won't be in a known state until after a safe remounting. At which point you can perform a read and find out which writes completed.
During the journal replay or whatever that happens.
Yeah.
Restart that.
As with any normal disk.
Yep. So I think that the takeaway from this is that it requires OSD changes that are like relatively well defined and understood. There are some client changes also. Again, I'm mirroring that with stuff, but both, right? That means that libRedos needs to be changed. The kernel client needs to be changed. So if this is going to go, in order for this to actually be used, like we need to get all those changes upstream into the upstream kernel and into the downstream kernel and all that stuff. So
I have a few other higher level questions. So the use case here is for like low durability RBD images in OCS, right? So if the scale on that is intended to be tens of thousands and they're supposed to be created and removed cheaply, then we have this problem where we actually don't want big pools because the blast radius would be really high, and we can't have 10,000 little pools.
So my thinking here is that, yes, so I think you want to generally do this with like single PG pools probably, because having a replica 1 pool with anything more than PG num 1 is like RAID 0, and you're just like increasing the probability that you're going to fail. So in most cases, I think PG will be 1, although you could actually do anything, I guess.
Can we enforce that? And
I think we could,
can
but
we
I don't
enforce
think
a
there's
limit
any
on the
reason.
size?
I don't think you actually want PG. It could be like PG4. It doesn't literally have to be 1. The point is that it sets the blast radius.
Yeah, PG. PG num will usually be small. So it's not so much a PG count issue. And then the second thing is that if these are,
but we're going to need to do things like make sure that the PGF balance or the whatever doesn't change the PG counts. So we're going to need to exempt
It's a
these
per
pools.
pool on or off setting for that, so you can turn it off for these pools.
Yeah, you can use existing stuff for that. But the second part is that if we are thinking about these as analogous to disks, then I think there are 2 ways to do it. We could set it up so these pools are like actually sort of correspond to disks, and then you have like multiple RBDs maybe on the same disk/pool, right? So the pool becomes the failure domain, and then we have if there are lots of applications that are doing this, then they would have multiple. They would each have their own RBD that's in that pool. That would be one way to work it. And if we did that, then the number of pools is order the number of OSDs, so we don't have this like OSD map explosion, right?
Right. It just means OCS is now responsible for balancing users across. Which, fair enough.
Yeah. But I mean, they're gonna have to do that anyway for this to work at all, because they need to not have multiple replicas on one OSD.
Right. I mean, there's already each of these pools already has to have some like goofy crush rule that like pins it to a failure domain, and so I think basically have a pool for domain, basically, whatever it is. And that could either be, I mean, probably you want to push it all the way down to disk.
Do we have any pool count warnings in the system yet when we start getting large?
Well, I mean, all that stuff will be shaken out as we do testing on this, I think.
Yeah,
well, that was going to be my next thing I want to talk about, because like this is going to be weird for us to test, I think.
No, actually, everything we've discussed so far would come out even on a 5 OSD cluster. Even a casual use of this.
No, weird, not difficult, just like because it's not the kind of testing we. Maybe it is. It seems different than a lot of the testing we do.
What I mean is even a casual use of OCS will expose pretty much all of the usage problems because OSDs are small individually.
Yeah. It seems sort of inevitable that the sort of the management framework that goes around this, that's deciding what the domains are and making sure that they're in the application, whatever, that's going to be.
It already has to have some mapping between the 10x10 pools.
I don't know if there's no way around that part of it. But
I just mean that we're going to need to start writing tests for this EIO returns and stuff, and that's a little different than a lot of our testing is. And if we're putting this in Ceph, we need to actually write some purpose testing for it.
Yeah, I mean, we do.
It's very much like the full testing. There's full testing that works like this.
The full testing sets and unsets full, but with an arbitrary workload, and so it'll be a little bit different than that because
I think you want. Yeah, we need a client that like validates that it gets IOs back.
Yeah. Right. Exactly.
Yeah.
And that those IOs happen in sort of an orderly fashion. They don't get weird. Yeah, exactly. But I think the Redos model could be adapted to do that, probably.
Or just write a tool for this purpose, because you need to tell the tool when you've set the whatever. Like, it's tedious, but it's like not that much work, I don't think.
Yeah.
Oh, I see what you mean. You can, add it to Rados model so that you tell Rados model when you're setting the flag at everything.
Yeah. Although it might be easier just to have a separate tool, because as far as this is concerned, it doesn't really care what type of op it is. Maybe there's a distinction between read and write, but beyond that, like.
Watch notify is the only exception. That needs to be specifically tested. Everything else is fine. was going to suggest some clever, if we had the way, this way of limiting a set of PGs an RBD image could map to, then we could do something clever with recreating PGs, but it interacts poorly with this not wanting to permanently delete data concept. I'm not sure how we'd do that. So I think the pool per OSD is actually a really good solution.
Didn't we want the idea of like RBD masking for other reasons though? For like
Oh, sure. It's just not a solution to this. I wanted it to be a solution to everything.
right, got it.
Shucks. Yeah. Yeah.
Oh yeah, that watch notify thing.
I mean, the semantics are still the same. Like watch returns EIO or whatever the watch callback equivalent of that is.
Yeah.
And the client, no, I think it just all the watch data is therefore like explicitly
Discarded,
dead, and you have to set it back up.
Yeah.
Like that's it.
Yeah. Yeah.
That's
Yeah.
what the
Is
RBD
that
client is
gonna
going to do
happen
anyway.
automatically? Yeah. Okay.
It probably doesn't. This will probably be code that needs to be written in the objector. But like, I don't think it's that big a deal.
Yeah.
It does mean that RBD will have to deal with the EIOs for anything that's it's not triggered by a client. Like any of its metadata operations or watch notify type of things needs to handle errors on those.
Yep.
I think it does that for blacklisting somewhat.
Yeah.
Yeah,
Maybe similar.
well, we need to have this conversation with Ilya before we commit to it as a path forward.
It still seems like it's just work. I don't think any of this is hard to define.
I'm not
If we're
saying it's
lucky,
hard
it
to
actually-
define, but I mean, the RBD team is pretty small these days. It's been eviscerated over the last year or two, and if we think we're going to get it anywhere that anyone can use it in time for anything, we need to make sure that's plausible.
I think if we're lucky, the EIO handling and librd will just match the list. That's exactly what librd probably already tears itself down as soon as it hits a blacklist stop, right?
Something like that, yeah.
Like we kind of like Rados model to be able to continue operating or whatever tool we use to test this, but even that's not really necessary. We could make it so
Yeah.
the objector absolutely refuses to carry on when it hits this state. Or any IO context from one of those pools. That's probably what I mean.
Yeah, that might be the safest thing. Because then some other consumer that isn't librd or whatever that we didn't think about won't have some unexpected behavior suddenly. Yeah.
I mean, probably we shouldn't make the objector die any more aggressively than it needs to. But RBD is, like, no RBD user is ever going to continue operating without actually reinitializing RBD. Because no one's going to want to build some kind of an online reinitialize setup thing. It's too much work for no reason. We can just unmap and remount.
Yeah, the kernel client might need a little bit of extra handling there since it shares the objector layer among different mounts, but it shouldn't be too much.
That's a really good reason to do it at the IO context level. Or whatever the kernel equivalent is.
Yeah, the RBD layer in the kernel basically.
Okay.
Yeah, I think we've covered that one pretty well. Go to the file topic, scale testing. So the idea with this one is there are different ways that we can try to test very large scale clusters without necessarily having physical hardware to test with. We can't necessarily test the capacity or the performance characteristics exactly the same way without that same number of OSDs, but just having say thousands of OSDs in a very very small number of nodes, we can find lots of bugs that we wouldn't detect otherwise without a very large cluster, like things in the manager, the monitor, Ceph ADM, anything to do with like cluster-wide operations. So we could use memory-backed OSDs for this, like memstore, but I think we will quickly run into memory constraints. And if we want to deploy thousands of these, I think it might be more efficient to use a little bit of the persistent storage on disk for like the metadata pools, and the OSD's internal metadata for like PG log, PG info, that kind of thing, so that we can restart the OSDs and test peering and well, recovery of no data perhaps, but I was talking with Gabby about this earlier, and he was suggesting like having the data pools essentially be like dev null and dev zero, so writes go nowhere and reads return zeros or some deterministic data based on the H object.
What if we just, is there like a less intrusive model where we just like, for the sake of argument, take the Smithy nodes and instead of having those 4 LVs, we have like 40 of them. And then we take 100 of them and we have 4,000 OSDs. And then they have like actual data. They're running the full stack.
We could do that.
We're actually testing
to start
everything.
with.
Yeah.
We
have to tune memory way down because those nodes don't have a ton of memory, but like.
Yeah, I think we have to tune memory way down. We have to tune like RocksDB settings potentially to make it not use any disk space for its first level, like, or make it use all the disk space for its first level or something, so it doesn't have that giant spacing amplification.
Or even on like on the scale cluster, if we're using Ceph volume to provision OSDs, there's a flag in there that says I want n OSDs per NVMe.
Yeah.
I believe, and so you could just set that to like 16 or 32 or 64 or something, and just create a ton of OSDs. Build a, like,
yeah, I think that works for like a certain scale. Like I guess it's probably like maybe 100 OSDs per node. I guess what I was leaning towards with the object store backend replacement idea is that kind of bumps it up another order of magnitude.
I see. Okay.
Shrink the memory requirements and down to like 100 megs.
I mean, we could go whole hog and create an object store, or an object. What am I looking for? Object creation flag, whatever. Hint that says, I assume you're going to lie to me about the content of this object. And then create a pool flag that says, don't actually store any of the data for the objects in this pool.
Yes, it's a fake pool.
Mm-hmm.
Like the pool will store all of its metadata, it'll do all the usual peering stuff, it's got a PG log, but the actual objects won't have any data, they'll just return 0.
Is that easier to do at the cluster level than just making a backing store that does it automatically?
Yeah, because you need the metadata not to lie, and if you want to do this with Cephfs, like you kind of want the directories to work.
Yeah, same with RGW and its metadata, even RBD.
So actually, no, I think this is actually easier to do as a real Rados thing. Otherwise, the objects are also like sort of infer. I'm pretty sure this is a data pool, so I'm just going to lie about the objects. You could totally do it that way, but I think it will be a little bit more inscrutable to anyone who's trying to do this. And since
it could also just store OMAP and not
one of the points of this
data.
One of the points of this is for like scale testers to be able to use this feature, and there's something to be said for making it slightly less infuriating to use.
I wonder if we could get this for free if we made Bluestar do zero block detection and just not store it. And then as long as you write zeros, then you're not consuming any storage. You're just consuming the metadata for the objects.
Can FIO be told to just write zeros? That would do it.
Yeah, you can do that. FIO.
Yeah.
All right.
I get defaults even.
There's even a pool flag I would worry about RGW because it puts attributes on objects, and I don't know. Like there's.
Yeah, you still need like the effective OMAP or metadata equivalents even in data pool to be persisted.
Yeah. And like blue source should do this anyway, right? Like if you're writing zeros, like we shouldn't be writing zeros down. It's like a little bit silly that we don't
Yeah, I
already
think
do this.
RVD filters them out in the client side actually.
That would be a problem. Can we tell it not to do that? Rather perverse, but
You just so it creates the objects.
so that I'm saying, well, I guess we actually want the objects to exist, sort of, I guess, or do we?
And that's
Yeah,
what,
because we want the
for a
I/O to
lot
hit
of
the PGs.
for a lot of cases you don't even need the yeah.
No, it'd be nice to have the objects, right? And the,
Well,
So
maybe
you could have a
depends on what we're
library
testing.
option to turn off. They'd probably be
yeah.
pretty easy too. You just have an option if there isn't one already.
I mean, CStore already supports sparse objects, so it won't be difficult to support there either eventually.
Yeah.
Same deal.
Exactly.
Just needs to notice that zeros are being written and, not do it.
I mean, you could do the same with memstore. You could make memstore do the zero detection, and then you could also do this with a bazillion. Although the thing with memstore is that you probably want to test things like, stopping a bunch of OSDs and starting them up again, and like all those like crashing type behaviors, and memstore doesn't do that super well. Probably actually do want to write down everything else.
So, okay, so that makes it so that one way or another we're not storing the data in the pools. Great.
Yeah.
What the other limitations are that OSDs require a lot of memory. So that's the next limitation.
Right. And that's something
Big
we already want to
profiles.
look at because with the complete profile thing with the edge use case. So that fits pretty well because we probably already need to figure out how to reduce its memory.
Yeah.
Well, what I mean is if our goal is to test, 4,000 OSDs with, 3 machines, then no version of that's ever going to work. You can't have that many OSDs on 3 machines. We'll never be that efficient. So is that the kind of thing we're talking about
This
here?
is a really big machine, but yeah.
It really depends on the memory. Like if you're talking about like 100 megs per OSD, you've got.
Yeah, you can put a terabyte of RAM on a machine, right? We don't have any of those, but
Yeah, the Smithies are actually pretty anemic in terms of memory these days. They're like 32 gigs, I think.
Yeah.
I think what I'm saying is if the goal is to test how the monitors, which is what we're talking about in this scenario, behave, it might be a nice way. It might be nice if we could fake the existence of some OSDs, at least for some data structures.
And that might be that is a good long-term goal, but I'm not sure that we need that extra order of magnitude yet for what we've talked about.
I'm not sure it actually is. That's why I'm bringing it up. So the advantage.
So Joao did this. Joao wrote a bunch of like fake monitor OSD things, like I don't know, 10 years ago, and they've just languished. I periodically have to like touch them if I ever like change an interface, and there's all this like annoying test code that never gets run. Probably I have to go fix. I might have finally ripped it out, but I think the maintenance burden is like, I don't know.
Yeah, that's what I was going to say.
I think it's easier to. I think it would be easier, I think, to have OSD tunables that get them down to like 50 or 100 meg OSDs, and then run like.
Is that even
a bunch of
possible
them.
though?
I think so.
Whatever it is.
Maybe say it's 200 gigs, 200 megs, whatever it is, and then like run 24 of them on a Smithy, and then lock 100 Smithy. Like that feels like an easier path to.
I haven't looked at the memory usage in the OSD in a while, but I just remember Mark at one point said that getting it down below a gig was a little rough.
Well, from Mark's perspective, and the OSDs still perform I/O at a non-question.
Yeah, exactly.
We don't really care about that here.
Yeah, exactly.
We're not trying to test performance. We can like disable all the caches. We can tune down the size of any kind of thing in MaxDB.
And I think the problem with like
that's true because it was with his memory balancer code or auto tuner, so maybe it was just the defaults were too large. So
I guess the concern I always have with faking OSDs is that you're never sure that you faked it right. And so you might run this like crazy scale test and you're like, monitors are great, but like they're running getting fake OSDs that aren't real OSDs, and real OSDs
Yeah.
have some different behavior. That's the thing.
Plus,
That's
let's you get
something.
like the top half of the behavior, like queuing and I'll do the
Yeah.
major OSD
Right. And
parking
that also you
problems.
want to
Yeah.
test, right? It's not just about the
Yeah.
Yep.
And also, we aren't just testing the monitors. We need to test the manager too, and that
Right.
would be
And
more
all of that.
complicated.
Yeah.
I guess the truth is anything in the monitor or the manager is so performance sensitive that we'd be interested in investing this kind of effort shouldn't be there in the first place. There shouldn't be anything that scale sensitive in either of those places.
Right, and this
Yeah,
is how
I
we
mean,
discover
we
that.
can-
Yeah.
No, I'm saying
That's
so.
way
As soon as
too
we
simple.
identify something where this would be worthwhile, it would be time to remove it, not to test it well.
Yeah. Yeah.
So yeah, I think what I'm saying is I agree.
So blue store is zero detection. That's the
Yeah, it
that's
seems like the simplest
net of
path
this.
to get this running. And that to actually use this with like Tautology and deploy it, I guess we need to change how we are running things there a little bit too. We're still using like partitions on each device right now, right?
Yeah. Sorry, I was distracted.
Yeah.
Right now the Ansible job is the thing that every time the machine is brought up for a particular test, it recreates those like 4 LVs, and they're each 100 gigs right now. And so we could have an alternate Ansible or whatever it is. So we create, instead of creating 4 of them, we create 40 that are 10 gigs each. As long as BlueStore you can create a 10 gig BlueStore just fine. So yeah.
I think actually it's a lower limit there where we can't create a BlueStore below like 15 or
2
5 gigs or
gigs.
something like that.
Something. Yeah, there's a lower limit, but it's pretty.
But if we're talking about like hundreds of OCs, maybe we want to go even beyond what we could do with partitions.
My guess is that we're going to run out of memory on those nodes before we run out of enough disk to make stores.
So 32 gigs into 200 megs is 160 OSDs. We have like 4 disks.
Oh yeah, okay.
That's going to be 40. Well, I guess 40 partitions per disk isn't that unreasonable.
Yeah, they're LVs, so yeah.
That's like 30 gigs of partition roughly. They're 1 terabyte disks. So yeah, I guess that would work for the Smithies.
Some of
Okay,
them
so
have 400 gig SSDs, so they're smaller.
okay, they might be a little smaller.
I think the new ones are bigger. They don't make the little ones anymore. Yeah. In any case, yeah, I think it's fine.
Yeah.
Whatever it
It
is
says
that
they
like
sent to a
sets the
random
lower
one. It
bound.
was 850 gigs available, but
Yeah.
I thought the older ones were smaller than that.
Yeah, the old ones are definitely 400 gig or 490 gig or whatever, because they were only 400 gig. But whatever sets the lower bound on BlueStore is like, it's not like a fundamental thing. Is there some option somewhere? As for RocksDB, it's whatever or something like that. So those can be changed too.
Yeah.
Okay.
Okay, good, cool. It's turning out to be much simpler than I was thinking, so that's great.
And I like the idea of running big pathology tests, especially now that the scheduler will be able to handle it. Hopefully.
Yeah, exactly.
Yeah. Yep. Okay. Anything else?
I don't think there's anything else we missed with this discussion on the scale testing for now. I think that makes sense. Yeah, any other
Can we
topics?
back up a little bit and justify to ourselves why supporting Replica 1 is a good idea in the Ceph project? I'm not saying it's not, I just, like,
Gonna play devil's advocate?
what, Josh?
Gonna play devil's advocate?
I I just want to make sure we're really convinced it's a good idea, and I'm still conflicted in my head. I mean, it's,
3x reduction in storage space for application level replication. That's why.
no, I
Anything
understand
that
why you don't want to do replication, but I mean, like, do the things we provide, are they really worth it to anyone, to people who are just want a local disk?
So I think the counter argument is that maybe these things should be using the new local storage operator thing that we've been talking about, and they shouldn't be using Ceph at all. And obviously that has the benefit that you get better performance. You're not using this complicated stack to do it. I think the counter argument to that is there are cases where I think there are cases where Replica 1 makes sense and you want the full feature set that Ceph provides, like RBD mirroring, for example.
Well, yeah, so can we
An
talk
option.
through that? Because, well, like, RV rearing, really? Because, like, all the things I've heard about will do that, I thought. Like, the point is that there are applications that do that kind of thing in the application layer.
Well,
So,
actually,
no, you wouldn't want RVD mirroring.
well, suppose you've run your analysis and you think 2 replicas is enough, but they can't be in the same data center.
Or maybe imagine an edge site where you've got something going on your edge site and you only have one replica because it's like whatever, but you want sort of a DR copy.
Then you can take easy advantage of
well, but I mean, those are all
blue store compression and
application
encryption.
based.
Yeah.
I mean,
No, I mean they're not though. That's the thing. Like if a however many minute delayed RBD DR replica is sufficient for your use cases, then your application doesn't have to support it at all. You can just stick XFS on it, do whatever it is you were going to do, and you're done.
Yeah.
Ship it.
And your edge cluster blows up, then you redeploy it and you restore from your jigger. Yeah.
Okay.
You can
So
kind of do
is
that with
actually
like
better than just doing that with, like, Btrfs send or whatever.
I mean, maybe you can do that with like LVM snapshots and like mirroring diffs and all that stuff. Like maybe, but I think there's if everything else is already Ceph, using the same set of interfaces or whatever, I think would be nice.
Well, and if you deploy it that way, like now each node also needs some LVM space, right? So you can't just give and take that back from Ceph. You'd have to.
Right. That's the other problem. Yeah.
It's like a whole thing.
All right. Yeah, I was thinking more about like snapshots and things, and RBD snapshots are actually like they import and export to all kinds of formats, but I hadn't considered it for the DR. Yeah.
I think this falls into the case where if this is the only thing that you want to do, then Ceph is the wrong tool. But if you're using Ceph for like 95% of everything else, and you also need to do this one thing, then there are a lot of advantages to also doing this with Ceph.
Okay.
And unfortunately, there are a lot of things that fall into the category, and at some point you have to limit the scope. But this one keeps coming up. So.
Yeah. All right.
And I think it seems like there's a relatively modest effort to like have the semantics be well defined, so that we can do it.
Yeah, I'm not really worried about like our being able to develop it. I'm just worried about like keeping it working process wise.
Yeah. I don't envy whoever has to write the OCS piece of this that's like actually doing the orchestration, doing all that other stuff. But yeah.
Yeah, that's going to be a thing. We would like Ceph probably to be making the call about when a pool should get marked EIO. Some kind of exposed, I believe this pool to be probably not useful right now. So there'll be interface level work.
It could be a manager module that's like.
Yeah, exactly. Something like that.
Whatever. Yeah.
But what I mean is the hooking inside of Ceph.
Do it in the monitor whenever we mark an OSD down?
No, because that's not necessarily enough.
It's it's a policy thing.
Like
Like
what?
maybe that's what the environment user administrator application wants, and maybe it isn't. So I really feel like we could implement a particular policy in a manager module. Some external thing could implement its own policy and just call like Ceph OSD pool set flag EIO, whatever. Like this like opens up all those possibilities, and so we have total flexibility.
All right.
What makes me really nervous is like saying like this is what the policy should be, and this is the only policy we support, because I highly doubt that that's going to cover everybody's.
We're probably going to have to identify the relevant use cases and give opinionated guidance,
Exactly.
so.
Like this is what we suggest, and we'll implement some particular policy, but like, a year down the line, we're gonna be like, we want to do this too, or different.
Oh.
Whatever.
Yeah, so they piggybacking on existing RP failures and infrastructure probably makes sense as a default kind of policy in my mind.
Sorry, what was that?
Yeah.
Like piggybacking on on our existing RP mechanisms and failure detection to like using down or out as a time.
I guess I would want. Yeah, I guess I would at least want to like implement that as a default policy that you can enable or disable in the pool. That you just set EIO when you lose an OSD.
This is what
because that's going to be the one for an awful lot.
What I mean is that there should be business logic in Ceph that takes the raw information from the current stats and makes a choice based on the set policy.
Yeah.
That business logic should live in the manager and not in OCS. OCS should specify the policy, not the implementation.
Yeah.
Otherwise, we get into things like OCS interpreting really specific details of like PG status, which is probably not a good thing. We want OCS expressing intent, I think.
Yeah, I think that's
yeah. Because we're also going to need to not do things like mark all the pools down as soon as 100% of PGs go unknown. Well, that's another reason that if we can put the policy implementation in the monitor, we should instead of in the manager.
Seems managery to me.
I think manager is fine, because manager actually has manager has a little bit more information in this case actually, but
like this isn't critical to the cluster itself continuing to function. So manager.
For anyone who's using these, I'm not sure if that's an accurate statement.
Cascading failures. That's the problem. Failing to mark something as an EIO pool isn't going to make the cluster situation worse. Maybe the application worse, but
no, I just mean like because Kafka or Cassandra or the things that that I've heard about being mooted as clients for this are going to be sort of the root applications that everything else gets built on top of. So if they're not working, it is basically going to be as if the storage cluster isn't working from the cluster user's perspective.
Yeah, I wonder what the like failure time, what they would expect. Like, did they want IOs to start EIOing after 15 seconds? Or like
much faster.
Like a SATA drive will take
they want it to look
90
like a
seconds,
drive.
Right?
Not all
maybe.
of them.
I'm not sure. Hang on, I'm not sure this is strictly a property of a SATA drive. So this is, I think, more about OCS setting up another replica. That's the interesting time.
But it needs to know at some point. It needs to know that system isn't just slow. It's like it failed.
Oh, I know. What I mean is the time frame is less about Cassandra's expectations of when a disk fails and more about how long you should go before OCS should start setting up another replica. It's replication delay, I think, not the application's internal expectations. Or a recovery point objective, whatever. Time you're allowed to be degraded.
Maybe. I think this is like something that the application people would have to answer, because like you don't want your Kafka stream to just freeze for 90 seconds.
Right,
I don't think it
would. Probably.
This lays around latency where you consider the failed if it starts performing poorly.
So I don't think none of those, well, at least I don't think Kafka or Cassandra will freeze simply because one of the nodes freezes by design.
Okay.
But you're right. That's something we'd have to check with the applications about.
Yeah.
I think the good news is that the fact that like I thought it's like I thought there was some category of device. Maybe it's not SATA, but it's like the non-enterprise, whatever, where like you can get IOs that just take a long time before the firmware decides to time it out.
Yeah, that happens a lot on
Like,
consumer
at least
drives because they assume there
consumer
isn't
drives.
another copy.
Yeah.
So at least in that
But
case,
that's-
there's like some precedent for our behavior, and so hopefully the application will deal with that.
Well, I
Maybe
mean,
it's be able to
we're
deal with
part of the reason we got kicked this problem is because it didn't.
it. Well, we
Uh,
hang forever.
Yeah,
We never
and
clean up.
Kafka never like decides that it's dead because we hang forever. That was the specific example I heard
Okay.
at least.
Yeah.
And so I think Kafka expects us to return an error in a reasonable amount of time.
Or they expect that like the orchestrator just killed the node. That would also work, right?
Yeah.
That's what I'm saying.
Yeah,
I'm
sure,
not sure
but I
this
mean,
is so much application correctness as how does it behave when a hang happens, and how long are we supposed to wait before spinning up another one?
Yeah.
Oh.
Because with Kubernetes, you're going to be setting up what do you call it? Replica Ceph? No, I forget. But it's like Kubernetes, please keep n of these alive, basically.
So if I remember correctly, Sahina has was like a weekly call about this replica one discussion. Whenever the next
Yeah.
one of those is, whoever is in there should basically like present this solution and like make sure that the rest of the people lined up around it like approve.
Is there an upstream like OpenShift data foundation thing? Or is that I think that's Red Hat internal.
But the call is that call is what it
Yeah.
is. But I mean, there's OpenShift Origin or whatever.
Yeah, okay.
The Git repository. I think I don't know.
Yeah.
Whatever.
Yeah. Well, I don't know that any of us are in that meeting.
Josh, do you know who's on that call?
I think
Get
Reed and Josh Solomon, who were good folks to talk to
Okay.
about that. They're
Yeah.
there.
So we talked about it on Tuesday with both of them, and I can't remember. I think I mentioned this, but we should basically flag it, make sure they bring it up for when
Yep.
it's just joined. Yeah.
Cool. Thanks, guys. Appreciate you hearing me.
Cool. Okay.
Any last minute other ideas? All right, well, that looks like I'm almost faded to darkness here, so I think it's time to call it. Got some lights on.
Later.
All right. See y'all next
See ya.
time.
See you guys.
Bye.
Thanks.